Okay, so first, just a little bit of a review. An exponential equation is of the form b to the e equals a, where b is our base, e is our exponent, and a is our answer. Okay? And then a logarithm, we have to bay it, if you remember. Easy way of remembering it. So we take the log, and then it's b, a equals e. So log base b of a equals e. Now before we get started, I want to go over the properties of logs really fast. This is what our notes were over the time before this, before spring break. So if we have log of two things being multiplied, so x times y, for example, then we have log of x plus log of y. If we have log and we have division, so x over y, or divided by y, we have log of x minus log of y, our denominator. Then finally, we have log of x to the y, so a power. And the power rule says that that y can move out to the front. So we have y log of x. Okay, so those are our three properties that we're going to use. Really, we're going to focus on one today. We're really going to focus in on this one right here. So if you don't know that one, I would pause and give that one some practice. All right, jumping right into our examples here. We have 3 to the x equals 18. Now logs help us solve for exponents. There are several ways of going about it, but I'm going to show you one way so that it's concise. You can use the same thing for every single problem, and you don't really have to worry about what to do for each problem. It's the same every single time. Okay, so step one is you're going to isolate your b to the e, or b to the x sometimes, is what we'll really refer to it as. So we have 3 to the x, it's by itself, 3 is the base, x is that exponent, it's by itself, so we're done. Our second step is we're going to take the log of both sides. So I'm going to have log of 3 to the x equals log of 18. So then we use properties of logs if needed, which is needed because we have an exponent here, so that can move out to the front. So this is going to become x log of 3 equals log of 18. That's the only really rule that we can use, so we'll just stop there. And then our fourth step is to solve for a variable, which is x in this case. So in order to solve for x, x is being multiplied by log of 3, so we're going to divide by log of 3 to undo the multiplication. And so I get that x equals log of 18 divided by log of 3. All right, so you'll notice that this right here is our answer. Another reason why I like using this method the best is because then I don't have to use the change of base formula, which ends up putting it in this form anyway. So let's go ahead and go over to Desmos and just type that in to see what value we get. Darn it, I'm not connected to the internet. Okay, never mind. I don't have Wi-Fi, so It's creating a little bit of a mess for us right now. I'm not even sure how this video is recording. That's fine. Okay, so I guess I have Desmos on my phone. It's just a little bit harder to type in. Divided by. So you just type the words log if you're using your phone, in case you're wondering. Log of 3. So we get 2.63. You can't see that. 2.63 is what we'll put. You're going to use these because it's about 2.63. It's not exactly. Okay, so that right there is our answer. From here on out, so just so we can know what we're talking about, this is approximated, and this one right here is exact. From moving forward, just use exact form. Unless it tells you otherwise. Okay, so moving on to our next example. I've got 2 to the x equals 10. If you feel comfortable, go ahead, pause, try it by yourself. If not, just keep moving along with me. So we isolate b to the x. Done. Did it for us. 2, take the log of both sides. So I have log of 2 to the x equals log of 10. Done. Then we're going to use our log properties. So I have log of 2 to the x. Because I have that exponent, I can move it out to the front. So I have x log of 2 equals log 10. There's no more properties for us to use. Now we solve by isolating our x. So we're going to divide by log base 2. And so we get x equals log base 10, or I'm sorry, log 10 over log 2, right? And because we're leaving exact, we'll leave it just like that. We cannot divide 10 in 2. That's not how this works. You'd be violating the log property. So don't, this is not equal to log 5, okay? That's just not right. Oh no, don't do that. Can you see that, maybe? Out of space here. All right, I'm moving on to the back now. Okay. So continuing on. First, isolate b to the x. So I know we have x minus 2 here, but it's still isolated. So our b to the x is isolated. Then we're going to take the log of both sides. So I'm going to have log 8 x minus 2 equals log 8 to the 6th. Now we're going to use the log property by moving those to the front. So I have x minus 2, because that's the whole exponent, log 8 equals 6 log 8. Okay, so we used that property on both of them. Now to solve, we're going to have to do a few steps. First, let's go ahead and distribute this x minus 2 through. So we get x log 8 minus 2 log 8. If we take that x minus 2 and multiply it through. And this side, we're going to leave the same. Let's go ahead and add 2 log 8 to both sides. Oh no, my computer's going to die. So we have 2 log 8 plus 6 log 8 gives us 8 log 8. And then we have x log 8 on this side. All right, finally, I have x with the log 8, and I have log 8 over here, so I'm going to divide by log 8. And then I'm left with x equals, log 8 divided by log 8 is 1, and I'm left with x equals 8. So that right there is my answer. Okay, there was an easier way of doing this problem that I want to show you. Notice that we have the same base. You can do it the same way each time, or you can use this little trick on problems just like these. If we have the same base, I can set the exponents equal to each other. So I'm going to have x minus 2 equals 6, because those are my exponents. And then I solve for x. So I add 2 to both sides. I get x equals 8. So I have x equals 8 and x equals 8. So that is correct. That's a little trick. You can actually, you'll notice on this next one here, I have 9 and 27. Those bases aren't the same, but you can rewrite it. So 3 to the first is 3. 3 squared is 9, and 3 to the third is 27. Let's go ahead and do this problem using that trick that I just showed you. This is kind of a fun problem. Little extra something. All right, you don't have to solve this way, but it's just fun. So I can rewrite 9 as 3 squared and 27 as 3 to the third. I'm putting them in parentheses because if you remember before, an exponent to an exponent, we can multiply those values. So I'm going to multiply those through. So I have 3 to the 2x minus 6 equals 3 to the 6x. Now I have the same base. It's 3. So I can set those exponents equal to each other. So 2x minus 6 equals 6x. Go ahead and subtract 2x from both sides. Solve it like you would any other problem. 6x divided by 4. If we simplify, we have negative 3 halves equals x. All right, so that right there is our answer. If you want to, you can go back through and solve it this way, but this is just a fun way of doing it. All right, one last problem. 4 to the x plus 2 equals 7. I'm going to go ahead and rewrite that because I kind of cut myself off. All right, I would pause here. Try it on your own. If not, I would go ahead and go through and try it on your own and then check over your answer when you're finished. So isolate b to the x. Done. Step 2, take the log of both sides. Log of 4 to the x plus 2 equals log 7. Done. Use the log property. Move that out to the front. So I have x plus 2 log 4 equals log 7. Done. Now I have to solve. So distribute that x plus 2 through. So I have x log 4 plus 2 log 4 equals log 7. Subtract 2 log 4 from both sides. I cannot combine these because they don't have the same base. So I have x log 4 equals log 7 minus 2 log 4. X is with the log 4, so divide by log 4. These cancel out. Divide everything by log 4. We're going to go ahead and leave it just like that. So you get x equals log 7 minus 2 log 4 over log 4. There's really no point in simplifying